Alright, so we seem to have experienced some technical difficulties at the end of that video, so thank you for jumping to a new video even though this is the same topic. We were in the middle of writing out the model for the Northeast, so I just went back to those indicator variables and I'm going to plug in a 1 for the Northeast indicator and then a 0 for the South and the West, because the Northeast falls in this otherwise category. If I kind of rewrite that but group some like terms, I could see that the intercept for the Northeast is going to end up being beta naught plus beta 2, and that the slope is going to be beta 1. Since the lines are parallel, each region has the same slope for ownership. Now when we fit this model in R, you'll notice that the code is just the same. So there's nothing really different about actually coding this model in R at all. R is going to give you a table of summary output that shows each of the regions here. And so it's going to let you know that, like, okay, this is the Northeast region indicator variable coefficient, this is the South, this is the West. And so let's use that to go ahead and write out our fitted model. And now let's talk about what some of these coefficients mean. They're really not that different from what the coefficient meant for our other parallel lines model. And so the coefficient for ownership rate, we could almost interpret it just like our usual slope. So for a 1% increase in ownership rate, what do we expect to happen to mortality? Well, we expect the average mortality to increase by 14.37 deaths per 100,000 people, as long as region doesn't change. So that's our estimated slope for all the regions, because this is a parallel lines model, and so we're assuming all the regions have the same slope. So what about one of these coefficients? Let's do the one for Northeast. And so what this is really saying is it's a comparison of what we expect the mortality rate to be in the Northeast compared to the Midwest. And so it's compared to the Midwest. Remember, that's our reference group, and so that's where it gets the name, because we're going to end up referring to that group when we interpret any of these three coefficients. And so our interpretation might be something like, well, we know this is an intercept, so when ownership rate is 0, we expect the average mortality in the Northeast to be 0.93 deaths per 100,000 lower, since the sign on that is negative, than average mortality in the Midwest. But we could actually do a little bit better than that. Because the lines are parallel, I'm going to go over here and kind of draw a little graph. And so this graph isn't going to be entirely accurate, but it's just a sketch. So we have parallel lines. We know that the intercept for the Northeast is lower than the intercept for the Midwest. So this is my Midwest, this is my Northeast. And we know that that's 0.93. But since the lines are parallel, we could make that interpretation for any gun ownership value. So as long as gun ownership is fixed, we're expecting average mortality in the Northeast to be 0.93 deaths lower than average mortality in the Midwest. And so I'm going to go ahead and modify my interpretation. So I'm going to cross that out because we could be a little bit more general. We expect average mortality in the Northeast to be 0.93 deaths per 100,000 lower than average mortality in the Midwest. And that's true for any fixed ownership percentage. And so this p-value in the row for the Northeast is just testing whether the average gun mortality in the Northeast is different than the average gun mortality in the Midwest after accounting for ownership rate. So that p-value is just testing whether whether average mortality in the Northeast is different than average mortality in the Midwest after accounting for the effects of gun ownership. Okay, so you could do a similar type of deal for the South. So we're estimating that the South has average gun mortality 3.27 deaths higher than the Midwest for a fixed ownership rate. We're estimating that the West has average gun mortality 0.9627 higher than the Midwest for a fixed gun ownership rate. And the hypothesis test would work the same way as well. Notice in this that there's no way just from this output to do a hypothesis test that compares the West to the South. All of these are comparisons of these different regions to the reference group, which is the Midwest. And so in general, when we have more than 2 levels of a categorical variable, we usually either include all of those levels in the model or none. And so, for example, we wouldn't want to just drop the New England level because it has a high p-value, since the South has this really high p-value, really low p-value. Therefore, we would want to kind of keep this region variable in the model. But to more explicitly test that, kind of the better way to see if we want region in the model is to test all of those indicator coefficients at the same time. And so our test for whether region is associated with gun mortality after accounting for the effects of gun ownership is going to have a null hypothesis where those 3 indicator coefficients are equal to 0, and an alternative hypothesis where at least one is different than 0. Okay, and so it took us a while, but that looks pretty similar to our motivation 1. So this was our motivation 1 when we wanted to see whether weight or height were associated with body fat percentage. And this is now kind of a similar looking type of test. In the next video, we'll bring in the nested F test to talk about how we would actually carry this out.